All right, so today we're going to be talking a little bit about mathematics and sports, and in particular, one of my favorite sports is baseball. But this really works with any sport that has teams. So the idea is, I'm about to start a season of baseball, and one of the things that we need to know is which team am I going to play when? Which team is my team going to play, and when are we going to play them? And scheduling is one of the most difficult things in the sports. And the reason is because you have to have all the teams play each other, especially if you're doing like a round robin. A round robin means that each team is going to play each other team at exactly one time. Or maybe if you're doing like a double round robin where you play two times, it's still really difficult to figure out when you're going to play. And then if you have, say, 3 fields or 4 fields or 5 fields that you can use at one time, how do you know which teams are going to play on which field, when they're going to play, and how do you keep it fair so that like you have the same number of home teams and away teams? And so that's what we're going to talk about. We're going to use graph theory, which is a mathematical tool, to figure out how to actually create a schedule, which it works out pretty nicely when you're looking at the mathematics involved. So let's go play.
All right, so what we wanted to talk about when it comes to sports is basically scheduling. And scheduling is one of the most difficult things to do because what ends up happening is in some situations you may have on your schedule you may have a certain number of and the way that I like to think about this is I like to think about the sport baseball, but you can think about basketball, you could think about football, you could think about soccer, you could think about any sport. You could think about horseshoes, any sport where you have two teams that play each other, and you may have multiple games going on at the same time. So if I'm thinking about baseball, maybe I've got 8 teams playing baseball, and I have 4 fields, and I have 4 games going on at once because each of the 8 teams is being paired up into 2 groups of 2. Now, when we're thinking about scheduling, what we really want to think about where the math comes into play is for what's called a round robin. So a round robin, this is just an example of where every team plays each other exactly one time. So each team plays every other team once. Now, this becomes kind of difficult as far as scheduling because in the situation where we have, let's say we have 8 teams, so I'm going to do a specific example and use this example to kind of demonstrate what you're supposed to do, or at least one of the mathematical ways to do this. And say you have 4 fields. And let's name these teams just to make it easy: A, B, C, D, E, F, G, and H. So here are your 8 teams. The question is, how do you schedule them so that they play each other? Well, if you try to do this, just try to like brute force it, what would end up happening is you would say, okay, well, A is going to play B. Okay, so they're playing a game at field 1, and B's already playing. So C is going to play D at field 2, and E is going to play F at field 3, and G is going to play H at field 4. So this will be the first round. All of these teams are playing each other. Now the next round, A's already played B, so you gotta have this team play somebody else. So A will play C. Okay, so then who's B gonna play? Well, maybe B will play D. In fact, even looking at this, you might say, oh, A's playing who B played and A's playing who D played and B's playing who C played, so that works out. So then you could extend this. E plays H and F plays G. Okay, hey, we got round 2 going on. This gets really difficult eventually because if you think about it, A is going to play B, C, D, E, F, G, and H. A is going to play 7 teams, and so there are going to be 7 rounds. And as soon as I get to this next round, it should start to get a little bit harder to do. Who's A going to play? A could play D. Who's B going to play? Well, B has already played A. B has already played D. Right, so A's playing D. B could play C. And this might end up working out. So then E would play who? E's already played F. He's already played H. E should play G. And does that work? So then F will play H. And F has not played H yet, so we're okay. All right, so let's see if we can go to round 4. So then A will play, who has A not played? A has played B, C, and D, so let's have A play E. Who has B not played? B has played A, B has played C, B has played D. B could play, I guess that would leave me, B could play E. Nope, E's already taken, so let's play F. B plays F. So A, B, C, who's C gonna play? C's already played D and B. So C could play F, G, and D could play, I guess that would give me H. And that one works out. And if you want to, you can try to do the fifth one, and the sixth one, and the seventh one, and what you will soon find out is if you don't make good choices right now, eventually you'll get to the point where you'll have this last one right here, this fourth setup, and they'll have already played each other. And because you're doing a round robin where each team plays each other team exactly once, that's not something you want. So how do we deal with making this easier? The way that we deal with this is we use what's called graph theory. So in mathematics, there's a thing called a graph, and a graph consists of two things. It consists of vertices, or nodes is another name for vertices, and edges, which people also call lines or links. So when you're looking at a graph, the vertices or the nodes are dots. So here's A, here's B, here's C, here's D, here's E, here's F, here's G, and here's H. And so if we're thinking about teams and scheduling, what we can do is we can use dots or vertices to represent the teams, and an edge is any line that connects two vertices. So in graph theory, you have vertices and you have edges, and edges connect vertices together. Now, when we talk about a round robin, what we create is a graph. So I'm going to put some edges in. Now, since it's a round robin, I want every team to play every other team. So each edge is going to represent a game being played. So A plays B, A plays C, A plays D, A plays E, F, G, and H. And then the next thing is B is going to play C at some point. B's already playing A here. B will play D, E, F, G, and H. And you might be looking at this and saying, okay, well, how the heck is this actually going to help? But it is going to help. And the reason why is because if I draw this graph, I can actually see every game that needs to be played. And how I'm going to use this to make it easier on myself when I actually go to scheduling is I'm going to use the graph and the picture of all these games being played, and I'm going to color code it. So this graph is an example of what we call a full graph. A full graph is a graph where between each of the vertices there's an edge drawn for every pair of vertices. Now, how do I use this in order to construct a schedule? Well, the way that I'm going to do it is I'm going to color code these now. I'm going to draw lines for the games that I want played at the same time. So I'm going to do red is going to be the games that I want played at the same time. So I want A to play B, H to play C, G to play D, and F to play E. And so let me put the F and the H just a little bit easier to see. Okay, so that's going to be the red games. Oh, what about next? Well, the next games I'm going to do is I'm going to do B plays C, A plays D, H plays E, and G plays F. So those yellow games will be played at the same time. I got 4 fields, 4 games, and every team's playing at the same exact time. Well, what about next? How about C plays D, B plays E, F plays A, and G plays H? So those games will take place at the same time. What about the next game? So far we're up to 3 different rounds. We need 7 rounds. Well, I can see how to extend this. E plays D, C plays F, G plays B, H plays A. So we've got that round. What about next? Well, how about, we haven't done some of these more interesting ones. What about B plays H, G plays C, F plays D, and E plays A. So there's another example. So that's our 5th round. What else? Well, we could play A plays C, H plays D, G plays E, and F plays B. So there's another round. And we need another round. So let's go to, so now B's played F. C has not played G, so let's do that one right there. Actually, C has played G, but D has not played, D has played A. Which one rounds are we missing? So, oh, F has not played H. So F plays H, E plays, should be E plays A, D plays B, and C plays G. So there's another round right there. And what we end up getting is we see the idea here is that to build a schedule, what we're going to end up doing is we're going to color code these with what we call subgraphs. So what is a subgraph? So a subgraph is sum of the edges and vertices of the original graph. All right, so what I'm going to do now is I'm going to show you how to build the subgraphs for a smaller number. We could see that color coding was working pretty nicely, but let's say we take the subgraphs for just 4 teams. So we'll take the full graph A, B, C, D, and then we have the full graph because everybody's going to play everybody else. So A is going to play B, C, and D. All right, so which graphs are we going to have? So we could have A and B and C and D. A plays B and C plays D. So there's one subgraph. There's 2 edges, 4 vertices. A, B, C, D. Okay, and so A is going to play D and B is going to play C. There's another subgraph, 2 edges, 4 vertices. And then A, B, C, D, same graph. But now we're going to use these 2. So A plays C and B plays D. Now notice that if I took these graphs and I stacked them on top of each other, I would have my original graph right here. Right? So these subgraphs, if I put them together, make the original full graph that I had. So then how does this work mathematics into scheduling? The way that it works is that if we take a round robin, that corresponds to a full graph, a graph with a vertex for each team and an edge between any pair of 2 teams. Okay. Now, if we take subgraphs where we connect these in pairs, so like only each pair of teams has, so if A and B are separated by an edge, C and D are separated by an edge, but there's only one edge connected to each vertex, there's only one edge connected to each team, there's only one game being played at a time by each team. If we're able to find the subgraphs for these pairs of teams that build together to make the full graph, then this corresponds to how we're going to schedule. So in this case, if I have 4 teams in 2 fields, I'm going to have A plays B and C plays D the first time. Then I'm going to have A plays D and B plays C the second time. And then for the 3rd round, I'm going to have A plays C and B plays D. And so anytime you have that number of teams given and the number of fields given, all you've got to do is break down these subgraphs so that you can see how to schedule the teams properly.